Hello, good morning, my dear friends and my respected teachers. My name is Mohammad Shahbaz Akhtar, and I am a PhD student of IIT Patna. I am doing my PhD under supervision of Dr. Ani Gadhia and Dr. Sudhan Maji as my co-supervisor. My topic of presentation is cost-efficient mobile backhaul network design over TWDM PON. These are the outlines of the paper: introduction, network architecture, problem statement, the proposed algorithm, the proposed two-stage cable conduit sharing scheme, then results, and after that conclusion and references. In the access network, we all know that due to the innovation of different data-centric application, the network providers are striving hard to provide these to fulfill the traffic demand of the user. In the upcoming we are living in fourth generation of mobile network, and the fifth generation is on the way. And we are expecting that the fifth generation will have the dedicated data rate of 1 Gbps to the mobile user, and 10 Gbps of without mobility, the stationary data. To fulfill this demand, we need to enhance the macro cell base station and small cell to as much as possible. But doing this, it is a very expensive for the network operators. So we have to define the procedures and algorithm so that the deployment cost for such enhancement of base station on a small cell can be promoted. At present, most of the network architecture radio access network are distributed radio access network. By distributed radio access network, we mean that at the cell sites, the baseband unit and radio units are placed together with a very short distance, and the connection between them is a fiber connection. And what is the backhaul then? From the baseband unit to the operator center office, the link or the connection or the infrastructure of network is we termed as backhaul, and from the baseband unit to the radio units, radio remote head, it is front haul network. So my work in is to design this backhaul network fiber express. Obviously, we are not talking about the microwave backhaul, because it cannot afford such a high traffic rate. So fiber is a better option. So my work is to design this backhaul network by proposing certain algorithms, certain optimization scheme, so that the deployment cost can be reduced significantly, and it can provide the network operators benefit to enhance their purpose to increase the architecture, increase the density of the architecture. So among the different variation of fiber based technology transport network, the TWDM PON, time wavelength division multiplex passive optical network, is acknowledged as the best technology and cost efficient technology for this purpose. In TWDM PON, we have the combination of two passive devices. Firstly, what is the passive optical network? Passive optical network is a fiber-based technology which uses a passive device in the remote nodes, unlike active devices. It doesn't require power source to operate, so operational cost is reduced significantly. First benefit we can get from here. Also, in TWDM PON, we have the combination of wavelength, number of wavelengths, and sharing of wavelengths. It has two passive devices. One is a arrayed waveguide grating filter, which has certain split ratio like 1:4, 1:8. The number of output ports is the number of wavelengths that can it multiplex or demultiplex. Each output port of a AWG device is went to the input of power splitter, which is shared in time domain among the user. That means each wavelength is shared between the multiple user in TWDM PON. So my purpose is to my objective is very clear, that what I have to do. Now what is the contribution? In this work, we have proposed a recursive clustering algorithm for designing the backhaul architecture of a DRAN system. So what RCA does, it explores the optical number and size of ONU or base station, same, because both ONU is connected with the base station, that we are using the same term for the purpose. We explore the optimal number and size of ONU cluster. Firstly, we decide we make a clustering. We make the cluster and decide the most suitable location for passive device placement and best fiber route from the operator central office to the given ONUs. This is the one way to reduce the cost. Another technique to further enhance the cost saving is two-stage cable conduit sharing. Suppose that in certain cases it's happened that a splitter has 5 base stations connected with it. We don't need to provide dedicated link for each the connection, because the fiber deployment comes at the cost of trenching and labor cost of trenching and laying the fiber. So what we do, we try to share the conduit as much as possible so that the cost can be reduced. In two-stage cable conduit sharing, in the earlier work, which most of the work are one-stage cable conduit sharing, that means only the last mile fiber is cable conduit sharing is employed in last mile fiber. But in this case, we are using two-stage cable conduit sharing, that means in the last mile fiber also, in the distribution fiber also, we do the same purpose. To check the performance of the proposed model, we compare our scheme with two benchmark scheme, popular benchmark scheme. One is base station clustering and another is the random cut sectoring scheme, and what we will see it will discuss in the result section. This is the proposed network architecture. In the left side we have the core network, and at the user side or the base station side we have the different number of base station. In between we have to deploy the TWDM PON architecture. Here is the central office where the TWDM OLT optical line terminal is placed. This is the AWG device which multiplexes and demultiplexes. As we can see, the different number of wavelengths. Each wavelength in single wavelength is used for single different wavelength is used for upstream and downstream transmission. Lambda 1 is for downstream, lambda 4 is for upstream, and this wavelength is went through the passive devices, passive power splitter, which is shared among the time domain between the different ONUs. So our purpose is to design this architecture. So as already we have discussed what is the basic fundamental architecture of TWDM PON. It has 4 main components: TWDM OLT port, optical intermeter, 2 passive devices, AWG and power splitter, and optical network unit, which is placed near the base station. All the traffic of a base station is aggregated at the corresponding BBU, and which is then transmitted through the ONU with the assigned wavelength. What is the objective function? We have provided as the location of central office where we will put the OLT, and we have provided with the location of base station, and now we have to decide the architecture. We deploy the architecture in between. Our main objective is to reduce the deployment cost as much as possible. For reducing the deployment cost, we have to reduce the total length of deployed fiber. As the output of the algorithm, what we get is the number and optimal location for first stage and second stage remote node for passive device and AWG placement, and also the total interconnection, the complete interconnection detail from OLT to each ONU. Also, we will get the respective split ratio of passive devices and AWG in between. This is the recursive clustering algorithm. The popular algorithm which we already earlier deployment is used is K-means clustering algorithm, but it has certain drawbacks, because in K-means we cannot decide the optimal value of K for which the design is perfect. So it is hard to decide the optimal number of cluster that will provide the best design. So in recursive ONU clustering, what we do is for each value of for each number of cluster, we iteratively do recursively design the form the cluster up to a certain threshold value, and among this number of for each value of cluster size, we decide the best cluster among them. Then again we increase the number of cluster size and do the same process until we get for which value of which number of cluster we are getting the least minimum cost among all the number of cluster which we are using. So in RCA we basically used k-means clustering algorithm as a starting purpose for making the cluster, which have improved procedure to initialize the cluster centroids before moving with the standard k-means cluster optimization iteration. This is the proposed scheme. We cannot discuss in detail about the scheme, which is very clear. Everyone can understand. We have implemented this using MATLAB. Now what is two-stage cable conduit sharing? Already we have discussed what is two-stage cable conduit sharing. We can see that here is three different TWM PON is given. TWM PON has no scope for split conduit sharing. So we can see that from OLT to AWG there is dedicated link. From AWG to power splitter there is dedicated link, and from power splitter to all the ONU there is dedicated link. So this architecture will have the highest cost because we have to the labor cost will increase very large. The labor cost will be very large. In TWDM we have only last mile 5 cable conduit sharing. That means only the power splitter to one thing. If there is no cable conduit sharing, there will be a dedicated link to each ONU. But last mile cable conduit sharing, we can see that these two links are cut, and we use this a single. We try to maximize the sharing of conduits of ONUs. In this our proposal two-stage cable conduit sharing, what we do is we, along with using last mile cable, we also use the distribution fiber section for sharing the conduit. It is the explanation which we have discussed. So what is the now simulation setup? How we are getting how we are generating the nodes? We use the MATLAB for this purpose. In MATLAB we took a square deployment region of 20 km each side, where OLT is placed at the center. We increase the number of ONUs base station from 100 to 500, which is stage size of 200. All the ONUs are generated randomly throughout the square. And on increasing the step size, we make sure that the current already selected location of ONUs are not altered. These are the different cost values taken from the different references. This cost value may not be exact, but when we obtain the exact value, the cost can be replaced with the actual value. Fiber cost has been taken in $4,000 per kilometer. Labor cost of each TWDM OLT port, which depends on the number of wavelengths it support. Cost of power splitter per port, cost of AWG per port is given. This is the first result. It is the deployment cost for different deployment techniques. We already discussed that we compare our proposed scheme with the random cut sectioning approach, given the linear as random cut and base station clustering scope. We can see that for all the cases, for all the different number of ONUs, our scheme provides the least deployment cost with respect to the other two schemes. Random cut sectioning scheme is providing the maximum deployment cost, followed by the base station clustering, then our scheme which provides the least deployment cost. In the result one relative performance, we have shown the deployment cost and the total cost is reduced by at least 45.6% compared with the random sectioning approach, and 8.2% compared with the base clustering. Maximum, it is a maximum value of and the least value of sagging, at least this percentage of sagging we have obtained. This is the result for all the results are from our scheme, but it is the RCA only. That means there is no provision of cable conduit sharing. This is the RCA with single stage cable conduit sharing, and this is RCA with two stage cable conduit sharing. As we can see that without cable conduit sharing, the cost is significantly large. When we use last mile cable conduit sharing, the cost is reduced significantly, and with two stage cable sharing we further success in reducing the cost. However, the maximum cost saving is obtained after first cable conduit sharing, because the last mile fiber is the quantity of last mile fiber is highest among all the fiber, and distribution section is little the length of distribution fiber is relatively smaller than the last mile fiber. This is the percentage of different cost of involved in the total deployment cost. We can see that the last mile fiber has the highest percentage of cost saving, highest percentage of cost in the total cost, 76%, followed by distribution fiber cost and feeder fiber cost. The 3% device cost is only 3%. And among the 3%, the OLT cost is the highest, then power splitter, then AWG. This is a numerical result to understand what is the how the RCA scheme works. We took 100 ONUs. For the 100 ONUs, we can see that we generate a number of cluster from 1 to 100 for first stage clustering. That means to decide the location for power splitter placement. So so we can see that initially for a smaller value of cluster size, the power splitter to ONU's total distance is very large, and will increases after will start decreasing when we increase the number of cluster size. After a certain point, 18 number of cluster and total distance of 146.7 kilometer, we get the least value of distance, fiber distance, and then the increasing the cluster size, the cost length of the fiber starts increasing. So for the first stage clustering, we can say that 18 candidate locations are there for placing the passive devices. Now when we get the 18 location for passive device placement, now we again use RCA scheme to decide the location for AWG. So it is now 18. Now we provide 18 location as input, and then we decide the number of location for AWG placement. So we get that after four cluster size, at 4 cluster size the distance is minimum, and then again it starts increasing. These are the all explanation which I discussed. So what we now we conclude the paper is that we are proposed a scheme for designing the backhaul network. We have proposed two different strategy for enhancing the saving of deployment cost. First one is the RCA scheme, and other is the two-stage cable conduit sharing scheme. We have seen the impact of both the scheme on the total deployment cost. Among the different deployment cost, last mile fiber cost is highest, followed by distribution of fiber, then feeder fiber. Among the device cost, OLT cost is maximum, followed by power splitter and AWG. Simulation result confirms that the RCA scheme significantly reduces the total backhaul cost by at least 45.6% compared with the random sectoring method, and 8.25% compared with the base station cluster scheme. We plan in the future work, we plan to extend the proposed algorithm for cost and energy efficient CRAN front-roll design using WDM PON. These are all the references. Thank you.